Hey folks, and welcome yet again to another edition of Helium Hacks Happy Hour. My name is Travis, and I go by TTEG over on the Discords, and I will be your host this evening. So, I think we have a pretty kick-ass show tonight. It should be fun. Jose from over at Rack Wireless is with us, and he's going to be talking about some new FSK modulation that you've been working with.
Yep, that's right.
Excellent. No, I've been looking forward to that. We've chatted a little bit online about that, but I've been looking forward to you coming and sharing what you've been working with. So it looks like I recognize most everyone on the show, but basically this is a tech show. We like to talk about the technical aspects of the Helium network and developing in nodes for it, and anything else kind of on a technical level. We stay away from talking about fiat and speculation on this show. So we do like to hear your voice and see your pretty faces, so feel free to turn on your mic, turn on your camera, and if you're new, introduce yourself. If you just want to say hi, jump in. Last week, Nick was on, and we were talking a little bit about ChirpStack, which he's running over at Mateo Scientific, and if you don't have an account over there, you should definitely check it out, and it supports Class C devices on the Helium network, which is cool. And we kind of last week went through that and got his light up and controllable. And if anyone missed that, I think the video should be up here a little later, but I did want to just real quick, I got a demo set up that I think I can show here. Now, what you're seeing here, you should be able to see a terminal here, and this is coming from a Dragino 33222, which you should be able to see in the background. And these two LEDs over on the right here are for relay channel 1 and 2. And then we have the ChirpStack, and this is where we can push downlinks to it. And so, just for example, if we want to turn on both relays, we give it the code, which is 03, and then either on or off being 0, on being 1. So we say, okay, I want channel 1 relay and channel 2 relay to both be on. So I'm going to enqueue it, and look at these lights in the upper right-hand corner. Boom, it kicks both of those relays on. And we can see the terminal kind of scrolling back with what's going through on the connection, which is just connected directly to this Dragino here. But in the same way, we could say, okay, now I want to leave first channel on and turn second channel off and push that through, and bam, immediately we get that relay turned off. So I just wanted to kind of demo that real quick since we've been talking about it, and we've also talked about the shock collar implementation, which is now fully functional. So Jose, you want to get into your presentation here?
Sure, I'll share my slides now.
Excellent.
Thank you. Yeah, so good morning, good afternoon, good night, everyone. So today I'm going to talk about something I've been working in the past few weeks. This is to bring this weather station to the Helium network, and not just this weather station, but all kinds of sensors that are using a different modulation from LoRa. So hopefully we'll see this kind of sensors soon. So as you know, like radio is everywhere. There's no surprise to anyone on this call. We have all sorts of radios around, cellular, Wi-Fi, LoRa. And this is a really interesting app. I don't know if you saw that already. It's called Architecture of Radio. So you can just scroll around your iPhone and see all sorts of signals around you. This is something that I've been really passionate about, like detecting all kinds of radios, not just LoRa. Of course, in Helium IoT, the world's largest public network for LoRaWAN, we only look at a very, very small portion of that spectrum. So we mostly look at 868 or 915 in the US or 923 in other countries. But we look at very, very short portions of that spectrum. And currently all gateways just decode 8 channels of 125 kilohertz within that spectrum. So this is your typical LoRa1 signal there, and this is your typical the LoRa chirp, so up and down. That's how the signal is modulated. Of course, there are other networks on the deep in space that look at other radio signals. One big one, which I particularly like, is GeoDNet. So they pick up GPS signals all around the world. They usually coexist with Helium locations because you want the signals to be outside. Again, something that also helps with Helium. There's other projects like Nodal. So this is a project that uses your mobile phone to pick up Bluetooth signals around you from other sensors. And of course, we have now Helium 5G, which looks at the CBRS portion of the spectrum in a very, very structured way. So you cannot, it's not something that you can play around much with, unfortunately. But I was really intrigued when I saw Chris looking tweet about the Helium Bridge project. This is something I've been looking at for a long time. Been playing around with bringing FM radio like RTS data into Helium and other things. So this really got my interest, and I saw that they were working with the WS80 weather stations. I believe Cooking is also now doing ANT Plus devices for sports equipment, and is going to bring something else as part of that Helium Foundation grant. It's a really, really cool project, and I definitely encourage you to follow that along. I also saw their great YouTube video showing the first development of that weather station integration. And the way they did it, they created a separate device. So this is a device which picks up the signals from the weather station, which is not LoRa. It converts the signals into LoRaWAN format and sends the data as usual for Helium. So this does require a separate hardware. So you have to have that device, which costs, they said it costs around $40. Not too bad. It also brought my attention to an excellent project called RTL 433, which I've linked there below. And this is a project that looks at integrating all sorts of devices. So this is like thousands of devices out there using proprietary modulations. And the way they do it, they use SDR dongles to pick up the signal. So the WS80, like this one, this is the WS90. It's a little bit more advanced. It just detects rain. Is a very low cost weather station. This is why the reason the project got, so much traction, the Bridge project. So you can get it for $150. It includes rain, wind, temperature, humidity, pressure, and solar. In a very nice package, it's solar powered. You only have to put in 2 AA batteries for backup. It even comes with a connection to a heater inside, which you can melt snow if it gets to get low temperatures in the region. The only problem that is that it uses, usually you have to apply the Bridge, which is a separate thing. It connects to Wi-Fi, and it adds cost, and it's not ideal for Helium. It is available in 3 different versions: 433, 868, and 915 megahertz versions, which is now familiar for most Helium users. However, it does use FSK modulation, not LoRa. So what is this FSK thing? It's called frequency shift keying, and at the most simple definition is like, so you use 2 frequencies to send data. So you have 1 frequency for a 0, and you have 1 frequency for a 1. There are more complex ways of doing this FSK, but this is the basic binary FSK. As you can see there, this is very easy to implement. So it was created basically because it could reuse FM radio transmitter, which again is frequency modulation. So the technology already existed, and it was very simple to implement. And the result is that you get very, very low cost devices using this kind of modulation. And you can find it everywhere. So like I use FSK every day. Like I've got a garage car door open, so I press a button and it opens the garage door. most garage door openers use FSK, as well as do like barbecue temperature monitors. So all kinds of very low cost radio devices use FSK. That the green thing there is the soil moisture. Again, something that you can buy for like $10, and you can have a radio soil moisture sensor. However, what got me really intrigued is that I've been playing with LoRa for a while now. Some people might know that, and I've used FSK with LoRa in the past. So I understand that the chips from Semtech that power the LoRa gateways, like all the Helium hotspots, they do support FSK mode. It's there because it gives you a very high bitrate channel. So it's the very short range, but very high bitrate. So if you want to, I guess Semtech added that like for maybe firmware updates in the future, something like that, where you wanted to send a lot of data very quickly. However, it's something that is kind of kept hidden and it's not really used anymore. And it's in many band plans, it's not really used. So I had to dig around a little bit, to work that out. And if you look at the configuration for Helium, this is the band plan for Helium. This is the US version, but it's going to be the same for all others. You see that the channel FSK is actually disabled there. Some networks do enable it, like the TTN, they do enable it, but no one really uses it. However, there's a problem, like I can't really use just turn on FSK and just hope for the best. It wouldn't work because FSK needs a lot of configuration, and the packet forward as it comes for Helium and all LoRaWAN networks, it's expecting a certain sync word. So this is a signal that's sent over the air, just that the radio knows that it's meant for that radio. So LoRa uses its own sync word and its own preamble. So the preamble is again something to kind of activate the radio, and so the radio is aware that the signal is coming for it. Fortunately, the RTL 433 project does list all the preambles and sync words for most devices on FSK. So after I dug around on the source code for that, I did find the format, the on-air format for the packet. And also they have nice tools also, so you can to decode sensors that are not yet on part of the RTL project. They have a really nice set of tools. So with that information, I dug into the packet forwarder. So this is the standard Semtech packet forwarder, and found that you have to change the source code in a few places. One is like LoRa uses a different sync word size, so they expect 3 bytes instead of 2, so that you have to change that in LoRa K3HAL. And also, of course, you have to change the sync word. You also have to increase the preamble. So I believe standard LoRa only uses 4 bytes for preamble, but you see that on this on the source code for RTL, it says AAAAAAAA, so it's actually 6 bytes. So that you have to set that. You also have to disable CRC because FSK in the format will be very different for the SCRC. So it tends to be proprietary. So you just disable that. Unfortunately, you can do that for FSK specifically, so it doesn't affect the LoRa side. And the two last lines, so those are actual registers on the SX1302. They are not really well documented, so you have to dig around a little bit. But once you disable CRC, and also you have to change the way the signal is encoded, there's something called whitening for signals. This is a way to kind of standardize the signal so that when you have like a string of zeros consequently, it doesn't break, the radio doesn't break. So it kind of introduces bits in the middle. But there are different algorithms to do this. LoRa uses one. Fortunately, again, you can change that. So it uses a different lightning coding. And then finally so once you do these changes, you have to recompile the packet forwarder. Of course, you could imagine that in the near future, you can do this dynamically. So you could set the registers and dynamically. Once that's done, you need to go into your global conf, so your band plan, and finally enable it. But you do need to set the different bandwidth, and particularly the data rate needs to match the device that you are using. This is kind of tricky to find out the data rate. Fortunately, I had to use I had a SDR, so I could see the distance between bits. I calculated the data rate that way. It could be done a little differently, but this was the start. And the end result is that once you do this, your packet forwarder starts to get data from FSK, from your sensor. For the weather station device, this happens every 8.8 seconds, so you see it very frequently. You don't need any extra hardware, so this is all using the standard LoRa gateway, LoRa hotspot. You don't affect the LoRa channel, so it's still picking up the LoRa channels on their correct frequencies. Again, you only set this for FSK. And you basically get the data encoded like you would for LoRa. So once you decode this base 64 encoding, as usual, you get the data, and you can see that the two initial bytes are the device ID of the weather station. That means the data was picked up. You could go and decode the data using the structure I showed there on the slide. But yeah, I'll leave that for your homework. So there are some challenges now with the project. So of course, FSK sensors do not follow the LoRaWAN protocol. They don't join, for example, which is a bit of a pain. They also use a different CRC method to validate data, and each device will have its own CRC method. But also, the devices are usually plain text. So even like the garage door opens, I don't know if there are people just replaying signals and like opening people's garage doors. That's quite possible. And on the same way, like if you enable this, you don't want to pick up people's garage doors because you probably have some privacy issues with that. So I think this can only work for like weather stations and sensors where the data can actually be public, which is still good, I think, still useful. So what I'm looking right now is how we can publish this data using the standard Helium stream. So again, I think because you have no keys in authentication, you have to kind of subscribe to devices through their IDs on particular hotspots as well. So you have to specify the hotspot you want to listen and the ID. For rack devices, we can then enable this special packet forwarder with the right preamble and right sync word for the device you want to monitor. And then the hotspot can start sending data. So this is something I hope to work with the foundation on getting some integration with the Oracle infrastructure and the OpenLNS. And eventually through this pipe, we could deliver data to your home Shutterstock as well. So just a final example, this was like initially when I was debugging, and you can see the log files from the packet forwarder. And when there's a blink there, you can see the data being picked up on the packet forwarder. And so every 8 seconds, you'll see a little byte. It's broken. Yeah, there should be a second one. Yeah, there's a second one. Yeah, there's a lot of debug because I had all the debug enabled there too. kind of create this.
Are we all squinting at the screen? Like, the fuck does that thing say?
Just showing that the packet forward is really picking up the signals at every blink. There is a difference in range. So for this weather station, the maximum they specify is 100 meters. I think we will get about 50. So this is not like LoRa, where you can get a really kilometer or miles range. But still, it can be useful for many sensors, like this low-cost sensor when you want to monitor some just temperatures and weather, something like that. I think it can work well. I don't know if you have any questions.
I've got a quick question. You had mentioned that it is plain text and unencrypted. However, you could add, I guess, encryption on the application layer if you wanted to, have encrypted transmission there, right?
Yeah, so you could do that. I mean, if the hotspot itself could do the task of that device that Nick was working on, that bridge device. So the hotspot could know the format of the sensor and kind of encode it to a LoRaWAN format. I think that could work well as well.
Yeah, the interesting thing, you mentioned that, it could go from FSK as a bridge to LoRaWAN. And yeah, that would definitely be encrypted at that level. But then going in the reverse, if it could go from LoRaWAN into FSK, that is, garage door openers, you do have cars, you have a lot of conveniences. And most of those things are kind of differentiated by, most of the cars are typically amplitude modulation. And then frequency is just everything. So there's no real rhyme or reason with frequency. So like if you're trying to block out cars at a modulation level, block out AM, but you're going to miss out on certain things down there too. There's really, by device, no rhyme or reason for what they're going to use.
Yeah, that's why I think it needs to be done at kind of the OpenLNS side, because the OpenLNS can whitelist certain types of sensors. And
by ID number or something.
By ID, by the format of the packet, exactly. So you cannot trigger like people's garage doors. I think that's
exactly. I would kind of like to have it work on my garage door. I think just have it
yes, I know,
one place, but hey.
Yeah. But even like seeing the packet, so where people's got home, like they know, they opened the garage door, so okay, they must have gotten home. So this is not something you really want to publish, I think. Whitelisting the data is important, I think. But I think there are still many sensors but there is no problem with sharing data. So,
well, a lot of them just solve that by having the rolling frequencies.
Yes, as well. Yeah,
they sync up. Key fobs have
you,
counters, and so they.
The best ones do, but the really cheap ones don't.
No. Like we found out, Honda kind of skimped on that.
Oh yeah.
The really cheap ones open your garage door when a plane flies over. So
yeah. There was a lot of that.
I like the idea. It's great. Yeah, and both directions. It's bridge it all, bridge everything.
Yeah, it would be good. And I don't know if we can reward this or not. Let's see what comes out. I can see.
Yeah, that's interesting.
To do some tests.
You mentioned whitening a moment ago, and it's kind of funny because the physical layer is patented and pretty much black box, but it has been, a number of researchers have worked on it and kind of reverse engineered that to a point that you can usably work on this using something like GNU Radio. But a lot of this was, they initially looked at some of the patent applications for this, and that's how they were getting at the whitening. The whitening structure that was defined was completely not what is in use. And so that was kind of a rabbit hole that they went down that was just the wrong direction. Just a side note there. But
Yeah, I mean, LoRa has a very interesting story, definitely, even from starting in France, and that some rumors that there were some boyfriends and girlfriends involved. But it's a really good technology. I mean, it's a long range, and they solved a lot of the problems of the data integrity and making sure you get the correct. So yeah, but
Noisy environments. Yeah.
noisy environments, yeah, again, something that FSK is not really good at. So if you have a noisy environment, then it doesn't work. It breaks very quickly. Also needs a lot of bandwidth, like because you're changing frequencies, and when you change frequency very sharply, so you generate a lot of noise. But fortunately, it is the most used kind of. I believe that FSK is the most used modulation out there. So yeah, we have to live with it.
And is this something that if someone has a device and they want to learn a little more about it, I mean, you can go to the, at least in the States, you can go to the FCC, and there's a little shortcut URL that you can, enter the FCC ID on it, and it will give you a link to all the documentation that was filed for that device and getting the certification on it. And a lot of times you can learn a lot about how a device is talking by going through those documents. So.
Yeah, then you just find the frequency from the FCC ID, sit there and record some packets, play them back, and if it works, they're not frequency hopping.
Yeah. But the RTL project is really it's really good as well. Like you can buy a cheap dongle like the dongle. You don't need like a Pluto. Like a Pluto is good, but you don't need this. You can buy the RTL SDRs and
Yeah.
just
Like 20 bucks, I think.
$20. Yeah, so you can start seeing the radius around you, which is also super interesting.
And that's basically the C1101 chip, that's for most of the sub G. Yeah.
Yeah, but the Semtech chips also do FSK.
That was interesting. I didn't even know that about the 1302. I was like,
Yeah,
wow,
don't
that's hidden in there about an FSK.
It is hidden in there. Yeah, it's not used. But the device, the SX1261 and like the 62, and so the device chips also do FSK, and this is
Oh, I didn't even. Yeah,
something you could do
that's
that.
even better.
Yeah.
No, I'm just going to tell Dirk to come watch this thing, figure out what we missed and what we need to learn.
Yeah, I'm happy to join the channel actually, and kind of, I think we have a lot of common ground, I guess, like because I'm only looking at FSK, I can't look at ANT or any other protocol, but the bridge as a general kind of way to bring other protocols into Helium, I think definitely something that I want to work with. So
Yeah.
I'll definitely join your GK channel there and like discuss
Yeah,
this with Derek.
I think you're in one of them. I know Dirk is banging his head against the ANT thing right now, ANT plus.
It is difficult, very difficult. ANT is annoying.
But yeah, if we get that, that'd be cool. I've got a bunch of the WS80s, and if I remember right, Jose, the 80s and the 90s are pretty different. The 80s are like $40 cheaper.
Yeah.
Which is nice. And I think because we stumbled across them because the local paragliding club used them. In fact, a lot of the code that Dirk used was from this engineer who'd kind of set up how to send them over to a cell plan. So he's got it on cell. He thinks that Helium is a scam and a Ponzi scheme, and he won't touch it. And I was like, well, let's just see what we can do.
Yeah.
With it.
But the sensors, so the devices are very almost similar, identical. The only thing is the 90 has what they call the piezoelectric rain sensor on top. So I think there's little pads there that pick up raindrops and they count them. I think that's the only difference. The radio protocol is very similar. So actually all the work for the WS90 came from WS80 as well. They just added a few fields.
Oh, okay. I know that was the fear of the guy Joseph, who was local. He's like, when they go to the WS90 and they discontinue the 80, I'll have to do all this again. But it sounds
they're very similar. And it's already supported by the RTL project. made by the same company. So actually, not many people know, but this is done by OPRF, which is the maker of really low-cost LoRa modules as well. Not as good as RAC, but very low cost. So the RFM 96, for example, is a very popular module. But they make all kinds of low-cost radio chips as well, and they also kind of run this company on the side for devices.
Rad.
It's very confusing. So you'll see this under the name of EcoWheat or Fine Offset. So they sell it under a lot of brands. I think it will sell it. Don't quote me on this, but it might sell it as RAC as well in the future. It's a very nice device actually. I mean, it's not going to last many years. It's not a research weather station, but yeah, it does a really good job.
Yeah, no, we'll see how long they last. I know the ones we've got up right now seem to be working. The one thing that I saw on the cost side for Helium is, which is what hits everybody, is that because they're sending so many parameters, the packets are really big, and it ends up costing way more data credits. And then depending on how you want to visualize the information, that can be super expensive. So there's like the geekery side is like, can you do it? Which you can, but then there's the business side, is like, oh, should you do it? And I think right now for weather stations that are pushing out, because we're trying to push that thing out every 2 minutes, get updates. Yeah, it's a lot of data. So I think not to shift it onto the Helium bridge stuff, but yeah, there's a whole big long conversation there.
Yeah, it is sending every 8 seconds as well, which is it's a lot. Yeah, it's a lot.
Yeah. Is that the 90? Because I thought the 80 was every 5.6 seconds. I wonder if there's a difference in frequency between the two, how often they send.
Maybe you can change it actually. So they have kind of a downlink protocol as well, but you can use it to change the frequency.
Okay. Cool.
I think I have the one of the original 80 teardowns in a box here, still a GK.
Yeah, you do. I sent that to you. I bought 4 more, and I think my next thing on that bridge thing is I want to see how he'd take the device that Dirk put together, that's all prototype stuff, and make a board out of that. So there's like a Helium bridge board
Straight on it. Yeah.
But Dirk thought we'd learn, well, because he's the one who's learning it, he would learn way more by banging his head against the ANT plus. So I'm kind of left figuring out the how do I get this board made? But that's kind of an exciting thing.
Yeah, I was going down the SPI route. I'm like, there has to be some way to tap into SPI.
Yeah, I remember you were getting after with that thing, but it sounds like you haven't figured.
It was fun. Yeah, I learned a bit.
But on the weather station, so I mean, sorry, you can download the firmware actually, and the firmware you just flash it over SWT, so you can you can see you can decompile it if you want, disassemble it.
Okay, but it is compiled. It is the binary firmware that they make available.
Yeah, you can get the binary, and it's very easy because they use the standard SD. It's an SDM inside, and you can just decompile it very easily. I used it to look at the streams. I knew what we expect a little bit.
Interesting. That's a talk for another day or another series of talks. Decompiling and stuff, but
hacking device.
It gets deep quick. Yeah. Well, Jose, thank you, man. Thank you for presenting this.
Thank you. Thank you for the time to share this.
Following the conversation, over on Gristle King server about this. So.
Yeah, I will definitely join that.
Awesome. And if anyone wants to, I guess, contact you if they, want more information, or they have, a breakthrough and they want to show you what they've been working on, what's the best way for them to get a hold of you?
Or yeah, we can do it on the Gristle King server, and if people are there.
Excellent.
Sounds good.
Well, thanks again, man. No, that was great. It would be interesting to be able to bring that into the Helium LoRaWAN network, because like you say, there are a ton of devices out there that use it.
Yep, it'd be super interesting.
Well, we got, I guess, about 20 minutes left on the call. Does anyone else have something they'd like to chat about or anything? Oh, I did build something up. I know I've shown some of you this week. I could, let me see. I think I've got it in here. Hold on for a second. I know we've been talking about hard share, and I got at least an initial, and I've got a hub here on the bottom for all the USBs running through it. This is a really, really cheap USB hub, but I've got these plates up in the corner where I was working on the magnetic sleds, and then most of these are racks. But I had a couple. I was trying out a new printing enclosure, and I have batteries in these as well. So I guess these can be turned on. And this has one of the E5 radios. These are two different Xiaos from Seed. One is the Nordic, and the other is with SMD. And these sleds are compatible, including these over here, with the Unify enclosures. And so hopefully we can get that up and going and get that Nordic power profiler on it. Let me see if I can switch over views here. This is another thing I was kind of working on, and this is compatible, should be compatible. This is printed. This sled, this baseboard is compatible with the medium-sized rack Unify enclosures. And so, and then I wanted to put a battery source on it, but I've got just a bajillion of these, well, not quite, but 18650 cells, which they allow you to, it's a print in place. So I print this all at once, and it's spring loaded. And so I can pop an 18650 into it, and it has these little lips up on the top corners that keep the battery from shaking out. And then you can just use like little contacts that screw in the ends to wire it through. And then I just Gorilla Glued that onto the baseboard. So, but this is a neat little board here. This is ultra wideband for interior location. So without using GPS, this would serve as what's known as an anchor point. And so I'd have a couple of these like up in the corners or up against the walls, just mounted. And this has a NB-IoT that can be used for backhaul of the data. And it also has your ultra wideband IO unit. This is one of the baseboards, the 19001 baseboard that has dual IO modules on it. So I can run both of these. One being NB-IoT, one being the ultra wideband. I've been putting the magnets in these boards, and so they do kind of click onto the hard share and align themselves. I don't have the pins on this one, but as far as I know, it is working. I can get it to click into place, and then I can just plug the other end in and address that board, and it powers the board. So I thought that was kind of neat. Now I don't think I can really charge all of the batteries off of that like $10 10-port USB hub. I don't think it's quite rated for charging devices so much on it, especially with it all loaded up. But and then I ordered a grip of OLEDs. Everyone be careful when you order OLEDs, because in my experience, it's 50-50 hit or miss that your VCC and your ground pins are either this way or this way. And most of them do not have reverse polarity protection on them. So you plug them in once, and you fry them. So be very careful that it matches whatever you're plugging them into. And just be careful in general, because they're made out of very thin glass, and my monkey hands tend to just foul them up pretty bad. But they are nice little displays, and you can get them for different layouts where it's like all white on black, all blue on black, or maybe just the top strip is yellow, the rest is blue on black. But they're great little devices. Just be wary about that pinout, because it's definitely hit or miss. Yeah, I was talking a little bit with Joey about power consumption monitoring and using that on hardshare or on this hardshare instance, and what it would take to hook up like the Nordic Power Profiler device or one of the OD devices. But I'd like to make it so it's not just scriptable against against a piece of firmware, but where you could actually kind of remote in and just use the GUI on it, so you have full access to the graphical user interface that accompanies those different tools. And then the next part probably wouldn't be automatic. It would be, hey Teague, I need you to hook up this particular board with the profiler, and then it would just associate that with your account and make it so you could grab that board every time you hit hard share and not have to you know um, I'm not too hard to find. I'm usually sitting in this chair, but
One thing you might think about doing is if you had like your hub, okay, and then you had a multiplexer hooked up to the analyzer or tester. So the tester's just switching the power leads based on the hub on the USB, and there's your tap for each one. But the multiplexer's there's gonna be switching noise and a little bit. Not gonna be. I don't know if that'll screw it all up, but
I don't know either. But I did a while back get some little multi. I know we've talked about these, but I got some little multiplexer boards. And I'm not. I don't know. These are UART multiplexers, right?
yeah, that's about the only way that I could see to kind of do something. Oh yeah. Okay, for UART. Yep.
Yeah, it's a UART multiplexer, and it's one of those click formats, which actually the WizBlocks they support this format with one of their I/O connector modules, where you can just click. I don't know. I haven't thought, like I say, I haven't thought this all the way through.
Yeah.
But I don't know. It's something to think about. If anyone has ideas, I would welcome any help or any suggestions on that. I was kind of talking with Joey. I want to talk with some others over at the foundation about getting a landing page for this show, for the Hacks show, where you could access the Hacks printer. You could get a camera feed from the printer. You could see what's printing over there. You could submit, and interface with the printer if you need something printed. And then I can, if you're in the States at least, I could ship it out to you in like a USPS envelope, which has worked pretty well in the past. It's cheap, it's slow, but it tends to eventually get there. And then also having access to the hard share that allows you to, get an account, to have a particular board or a particular config that you're working with, set up, to your link to your account there, and hack away on whatever can be built up on the system. Or if you'd like to host your own and then kind of get plugged into this page, let's do that too. So but I just thought it might be convenient to have just kind of a landing page for all the craziness that we intend on talking about on this show. So
Yeah, sounds like a good idea. We could host a printer in Europe as well, connected to the same system.
what's that?
We could host a printer in Europe as well, right? Host
Oh yeah,
kind of on the same. They could select which one, and yeah, we could do that.
I like it. Yeah. I'm just running, I guess, Octoprint on a Prusa is what it is. But yeah, there's some different. Well, I mean, I used to have some ANET A8s on it. I think there's still some original parts on those printers. They're kind of hacked together at this point, but they work well. But yeah, that'd be cool to have one over there. And if you go to USPS and request, they will send you. I just asked for some padded envelopes, and I got a box that's like about 3.5 feet high by a foot in each direction, just filled top to bottom with those little envelope padded mailers, and it makes it very easy to print parts that aren't too delicate, I suppose. So I've seen, I guess, some folks recently have been playing around, with these flipper zeros and doing some modifications and some external, I guess, components that you can kind of click onto them. Is anyone working on a new one of those or on a new board that interfaces with those? Oh, I totally broke my flipper the other day too, by the way.
External GPIO antenna. It has a CC 1101 on it here. There you can see. And that goes right into the flipper GPIO. It really only reads through one signal, an analog signal coming out of this thing. The rest is just 5-volt power and ground in. But there's a CC 1101.
Cool.
Yeah, it works pretty well. I mean, it almost
Thank you.
it definitely improves the range a lot. So,
What I've heard.
and this is all sub G stuff. There's also an app that was just recently created that I saw that allows you to read and parse FSK for the weather stations.
I saw
So I don't have it. I can see that it's there, but the text file doesn't have the preamble or any of those keys set for it. So it hasn't worked for me. And they say that it only works with certain models, but people are doing that. So yeah, it's a pretty interesting little device. I mean, you could really the external one is probably at least, I get like 30, 40 feet with the internal antenna. With the external, it's probably more like hundreds of feet.
Oh, nice.
So I have a recipe of certain packets or like an AT commands. And it does have a terminal on it for UART, so you could tap that way too.
Gotcha.
I'd be annoyed by typing things in.
I've been working on just a real stripped down firmware that allows me to send downlinks with just a little macro keyboard.
Yep. A recipe. There's certain things you want to do for certain devices, and it's just map it. Yeah.
Well, I guess we're right at about an hour. This has been fun tonight, folks. Jose, thank you for the presentation. Thank you all for joining us this evening. And I guess on that note, we can call it a week. Everyone be safe out there and, keep hacking. And I'll see everyone hopefully next week. Same bat. Oh, we've got a cool talk coming up on Home Assistant integration with the Helium network. So you definitely want to check this out. It should be an exciting one. Same bad time, same bad channel next week. See you, folks. Adios.